In today's video, we will use the definition of the derivative to find an expression that represents our slope of our tangent line at a single x value, some value we'll call a. Our first method, we'll refer to that as our h approaches 0 way, where we have f of a plus h minus f of a all over h. Again, where a represents that specific x value where we are looking for the slope of our tangent line. And then the second method, we have the limit as x approaches a of f of x minus f of a over x minus a. So we'll begin at looking at method 1. So we'll have the limit as h approaches 0. Again, note we are going to work with 3x plus 1 as our function. So we're going to have f of a plus h. So that means we'll sub in a plus h where there's an x. So we'll have 3 and then a plus h plus 1. So that is our f of a plus h minus f of a. Now keep in mind, we're going to have to put this in parentheses. What f of a means is just replace all your x's with a's. So we'll have 3a plus 1. And that's all over h. So we'll continue down. We'll do the limit as h approaches 0. Distribute your 3, you'll get 3a plus 3h plus 1. We'll distribute the negative 1 through to give us negative 3a minus 1 all over h. Combining like terms, the 3a and the negative 3a add to 0. The 1 and the negative 1 add to 0. So we're left at the limit as h approaches 0 of 3h over h. Well, our h's cancel out, which is what we're hoping for, because then we could do direct substitution. Well, in this case, there's no place to even sub in an h, a 0 for h, so we just get that our limit is 3. Remember what we were finding? We were finding the slope of our tangent line at some given point a. Well, notice by our slope of our tangent line just being 3, that says it doesn't matter what our x value is, our slope will always be 3. And if we think about it, we had a line. We know lines everywhere have a constant slope. So that makes sense. We'll look at our second method now. So we'll do our limit as x approaches a. F of x, that's our 3x plus 1, minus, remember to put in parentheses, f of a, so that's 3a plus 1, all over x minus a. We'll distribute our negative. We'll get the limit as x approaches a of 3x plus 1 minus 3a minus 1 all over x minus a. Our 1's will add to 0, and we'll be left with the limit as x approaches a of 3x minus 3a over x minus a. We can pull a 3 out of the numerator. And that will allow us to cancel out an x minus a, so that we can then do direct substitution. So those divide out to 1. We'll have limit as x approaches a now equals 3. So what this is saying is everywhere we see an x, replace it with a a. Well, there's nowhere to replace it with an a, so we just get 3. Once you do that direct substitution, that is when the limit goes away. And again, this is showing that no matter the a value, which is a specific x value, our slope will always be 3. Well, we just saw our tangent line slope is 3 everywhere. Well, what if we wanted to find the equation of the tangent line at x equals -2? Well, that's -2, comma. We could plug in for x to see what our y value would be at that specific x value. That would give us -6 plus 1, so -5. And we'll use our point slope form. Y minus y1 equals our slope times x minus x1. Well, we'll have y minus a -5, which would give us y plus 5. Our m, our slope, that is the numerical value that we found from our limit. Well, we found it was always going to be 3 regardless of the x value. Now, let's say hypothetically we had in that limit gotten something like 2a plus 7. Well, then you would sub in for a the x value that you're looking at. But here, it was going to be 3 no matter what, so we don't have to do that. So we'll just have 3, and then we'll have x minus our x value. So x minus a -2 will give us really x plus 2. And that is our equation of our tangent line. If you wanted to rearrange it and put it in point slope form, you would end up getting y equals 3x plus 1. Well, because we have a linear function, the line that represents our slope at any point is just going to be the line itself. Now, we won't work with linear functions that much just because the slopes aren't that interesting. They're not changing. So let's look at a quadratic now. We'll do the same thing. We'll look at both methods. Again, f of a plus h means anywhere you see an x, replace it with a plus h. So this is going to give us the limit as h approaches 0 of 3 times a plus h squared plus 2 times a plus h. And then we'll have minus f of a. So everywhere we see an x, we'll replace it with an a. So we'll have 3a squared plus 2a. And this will all be over h. Well, we'll have the limit as h approaches 0. If we FOIL out a plus h times a plus h, because that's what it means to square something, we'll end up with a squared. We'll get 2 ah's plus h squared. We'll distribute the 2, and we'll get plus 2a plus 2h. And we'll distribute the negative to give us minus 3a squared minus 2a all over h. We'll continue to simplify by distributing the 3. And keep in mind, the reason we're doing this is we're trying to eventually cancel out the h so we can do direct substitution. So you should find that everything that doesn't have an h should end up adding to 0. So if it's not, you want to check your signs. We've got a positive 3a squared and negative 3a squared. Those add to 0. We've got a positive 2a and a negative 2a. Those will add to 0. So that leaves us with the limit as h approaches 0 of 6ah plus 3h squared plus 2h all over h. We can now divide everything by h, and it will leave us with something we can use direct substitution. So we'll get 6a plus 3h plus 2. Now we can do direct substitution, subbing in 0 for every h, which is just one place in this case. Once you do your direct substitution, that is when your limit goes away, and we'll just be left with 6a plus 2. So what 6a plus 2 is, it is an expression that will directly tell us the slope of our tangent line at any given value of a. And a is some specific x value. So for example, if we want to find the slope of our tangent line at x equals -1, we just put -1 in for a, and it would give us -4 for our slope. If we wanted to find the slope of our tangent line at x equals 1, we would put in 1 for a, and it would tell us our slope is 8. So this could now directly tell us the slope of our tangent line at any given x value, which is pretty powerful and makes it pretty quick then once you have that expression. We're going to look at our other method. Keep in mind we had y equals 3x squared plus 2x. And our other method, we have the limit as x approaches a of f of x minus f of a all over x minus a. So we'll start with the limit as x approaches a of f of x, which is just our original function, 3x squared plus 2x, minus, remember to put in a parenthesis, f of a, so we'll replace all the x's with a's, 3a squared plus 2a. And that is all over x minus a. Well, we can't do direct substitution because if we subbed in a for all the x's, we'd get a minus a in the denominator, making it undefined. So we've got to do some simplification here. We'll distribute our negative, giving us 3x squared plus 2x minus 3a squared minus 2a all over x minus a. As we combine our like terms, notice nothing necessarily cancels out, but we have a set of squareds and we have a set of things to the first. So we are going to group those together. So we're going to have 3x squared minus 3a squared plus 2x minus 2a all over x minus a. Now you'll see our algebra is going to be a little bit more challenging this one, which is why I often like to use the H way, but you can use whichever method you choose. We are going to first, we'll pull a 3 out, giving us x squared minus a squared, and we'll pull a 2 out, giving us x minus a. And that's all over x minus a. Well, when you're dividing, you can only divide something out if it's in each term. Well, a term is a set of stuff that's being multiplied. So this is a term here, this is a term here. The one on the right currently has an x minus a, but the one on the left doesn't. However, we could factor the one on the left. X squared minus a squared is really just x minus a times x plus y, our difference of two perfect squares. And now each term has an x minus a. So the x minus a in the denominator can divide out each of the ones in the numerator. And that'll leave us with the limit as x approaches a of 3 times x plus a plus 2. We now have something we can do direct substitution with. So wherever we see a x, we'll replace it with an a. Again, when you make that substitution, you no longer have a limit. Well, this is really 3 times 2a plus 2, which is really 6a plus 2, which is the same thing we got from the other method. Again, what this means, it's an expression that allows us to identify the slope of our tangent line at any given x value. So a is representing one specific x value. So therefore, if we want the slope at 2, we could put in 2 for a. 6 times 2 is 12, plus 2 is 14. Last thing for this video, from this graph, we are going to try and put in order 0, g prime of -2, g prime of 0, g prime of 2, and g prime of 4. You need to keep in mind that the primes represent the slope of the tangent line. So first off, at -2, we have a slope that is positive. So you can kind of sketch in the tangent line. At g prime of 0, So at 0, the slope of our tangent line is negative. At 2, the slope of our tangent line is positive. And at 4, the slope of our tangent line is positive again. So we want to put these in increasing order. So we want the smallest one first. Now keep in mind, 0 is just saying 0. Well, at g prime of 0, our slope of our tangent line is negative. So that's clearly the smallest one. So g prime of 0 should come first. Since that's the only negative one, the 0 should come next. And now of our 3 positive slopes, we've got to see which one has the least slope. And I would say the one on the far right has the least slope. That would be g prime of 4. Now the other two are pretty close. Okay, I would say the one on the far left, the g prime of negative 2, is slightly less steep than the g prime of 2. So we'll put that one next. And then to finish off, g prime of 2. So again, remember when you have a prime, your derivative there, that's representing the slope of your tangent line. So you can draw on your tangent line and see what that slope looks like. That's it for this video. We'll see you next class, period.